Scratch is a free desktop and online multimedia authoring tool that can be used by students, scholars, teachers, and parents for a range of educational and entertainment constructivist purposes, from math and science projects, including simulations and visualizations of experiments, recording lectures with animated presentations, to social sciences animated stories, and interactive art and music. Simple games may be made with it, as well. Viewing the existing projects available on the Scratch website, or modifying and testing any modification without saving it, requires no online registration. Scratch allows users to use event-driven programming with multiple active objects called sprites. Sprites can be drawn as either vector or bitmap graphics from Scratch in a simple editor that is part of the Scratch, or can be imported from external sources, including webcam. Version 2.0 of Scratch is currently available online and as a desktop application for Windows, Mac OS X and Linux. The source code of Scratch 1X is made available under GPL v2 license and Scratch source code license. The Scratch programming language is also used in the game creation tool Stencil. Origin of name: the name was derived from the tentabilisms technique of scratching, that is mixing sounds, relating the ease of mixing sounds to the ease of mixing projects made with Scratch. History: the first version of Scratch was developed in 2003 by the Lifelong Kindergarten Group, led by Mitchell Resnick, at the MIT Media Lab. The first official website was originally launched in 2006. Scratch 1.0 was then later available to the public for download on January 8, 2007. In March 2007, project sharing was possible and the whole Scratch website was completely redesigned. The public were able to create, share and remix their own projects as well as others. Scratch continued to update their site until late 2012 when they released Scratch 2.0, which offered many updates to the programming system and website design. There is also a downloadable version of Scratch. User interface. From left to right, in the upper part of the left column there is a stage area featuring the results and all sprites thumbnails listed below the stage. In the middle column in its upper part there are 10 tabs: scripts, costumes, sounds, looks, motions, operators, sensing, events, data and more blocks. Under Scripts tab, 8 groups of blocks, each of its own color and shape, appear. Individual block is testable under different conditions and parameters via double-click, or it can be dragged onto the scripts area to be part of the script governing a selected sprite. In blue color are blocks governing movement, whereas those governing a selected sprite's looks, sound, pen, control, sensing, operators, variables, and more blocks, are in violet, pink, dark green, orange, brown, goldenrod, light blue, light green, and ultramarine, respectively. When the group is clicked, all the blocks belonging to the group appear for selection and dragging. In the right column there is a script area featuring scripts, consisting of dragged blocks, that are linked to a selected sprite. Additionally, far right there is an expandable help area. In pre-2 versions, the blocks palette was on the left, in the middle were the selected sprite area and scripts area associated with a selected sprite, and the stage area with sprites thumbnails listed below it were in the right column. Community of users. Scratch is used in many different settings: schools, museums, community centers, and homes. For example, younger children can create projects with their parents or older siblings, and college students use Scratch in some introductory computer science classes. Via localization files downloaded with Scratch, its interface language can be changed to a language of choice since Scratch is used in different parts of the world. The Johns Hopkins University Center for Talented Youth offers an online course on Scratch programming for students in grade 6 and up through the CT Online program. Empirical studies were made of various theories. Those that interfered with intuitive learning were discarded, while those that encouraged beginners and made it easy for them to explore and learn were kept. Some of the results are surprising, making Scratch quite different from other teaching languages. Online community. The Scratch Online community's slogan: Imagine, Program, Share indicates that sharing and the social aspects of creativity are important parts of the philosophy behind Scratch. A few influential members of the Scratch online community made great personal strides in innovative methods with Scratch programming. Scratch projects are not seen as black boxes, but as objects for remixing to make new projects. Projects can be uploaded directly from the development environment to the Scratch website, and any member of the community can download their full source code to study or to remix into new projects. Members can also create project studios, comment, tag, favorite and love others' projects and share ideas. Projects range from games to animations to chatbots. All projects on the website are shared under a Creative Commons Attribution and Share-alike license and can be played in a web browser. The website receives close to 10 million page views per month, and as of August 10, 2014 it had 3,726,565 registered members, and over 6,100,000 projects. The website has currently got over 6 million shared projects. The website frequently establishes Scratch Design Studio challenges to encourage creation and sharing by providing users with a basic design concept. There are custom home pages for Mexico and Israel that display local content in some sections of the homepage. There are also local independent Scratch websites in countries such as Portugal and the United Arab Emirates. In 2008, the Scratch online community platform received an honorary mention in the Ars Electronica Prix. There is also an online community for educators, called Scratched. Scratch is also a fun literary structure, with online role plays that range in many different genres. Features and derivatives. The current version of Scratch does not treat procedures as first-class structures and has limited file I/O options with Scratch 2.0 extension protocol. An experimental extension feature that allows interaction between Scratch 2.0 and other programs. The extension protocol allows interfacing with hardware boards such as Lego Mindstorms or Arduino. In addition, Scratch 2 only supports one-dimensional arrays, known as lists. Floating point scalars and strings are supported as of version 1.4, but with limited string manipulation capability. There is a strong contrast between the powerful multimedia functions and multi-threaded programming style and the rather limited scope of the Scratch programming language. On May 6, 2013, Scratch closed for 3 days to update to Scratch 2.0. The update changed the look of the site and included an online project editor. A new beta version of the Scratch 2 offline editor is currently available. This version replaces the old Scratch 2.0. A number of Scratch derivatives called Scratch modifications have been created using the source code of Scratch version 1.4. These programs are a variation of Scratch that normally include a few extra blocks or changes to the GUI. Some of them additionally introduce shifts in underlying approach to computing, such as build your own blocks or shorter BYOB, by not only allowing users to build their own blocks, but featuring first-class procedures, first-class lists, and first-class truly object-oriented sprites with prototyping inheritance, which are not part of Scratch. BYOB was developed by Jens Ma Paragraph NIG with documentation provided by Brian Harvey from University of California, Berkeley, and has been used to teach the beauty and joy of computing introductory course in CS for non-CS major students. The source code of Scratch and its derivatives are based on Squeak, which is based on Smalltalk 80. Version 2 of Scratch is implemented in ActionScript, with an experimental JavaScript-based interpreter being developed in parallel. See also. The following youth computing projects also originated in the MIT Lifelong Kindergarten Group, Computer Clubhouse, Programmable Cricket. Other educational programming languages include Microsoft's Small Basic, Microsoft's Codu, RoboMind, eToys, Stencil Game Creation Tool, Greenfoot, NetLogo. References. External links, official website, Scratch at DMOZ, Scratch WikiWiki website, Scratch plus Arduino Drive Robots etc., Scratched.